In this video, we're going to look at the Diels-Alder reaction, but we're going to focus on the endo rule and how it applies. Let's jump right in. In the Diels-Alder reaction, when I zip, we make cyclohexenes. And I've been drawing them this way, but that's not really the shape of that. If I draw it out better, that cyclohexene is actually a bent, folded over pocket. It's got a little pocket inside of it. This is the inside the pocket spot, or the endo of the pocket. Endo means inside. And this top part is the outside of the pocket, or the exo, the outside part. So this is the inside endo spot, and this is the exo outside spot. So if I have groups on here, this one that points down points more towards the inside. We call that the endo site. And this one that points up into the outside is called the exo spot. This down one would be endo. And this one points up and out, so it's exo. Now the endo rule just says, if you start with a carbonyl group on here, and you end up with a carbonyl group here when I'm done, the carbonyl group, when I have two choices of where to put it, I have a hydrogen here and a carbonyl. The carbonyl, or things with pi bonds, end up being endo. So if I redrew this out carefully, this carbonyl and hydrogen are right here. The hydrogen will be exo, and the carbonyl is down here, endo, inside of this pocket. Now it doesn't have to be a carbonyl. It can be anything with a pi bond, like a nitrile, a nitro. Things that have pi bonds like that like to be tucked in the inside of the pocket, or endo to the pocket. Hence, the endo rule. Please subscribe so I can continue to help you with your organic chemistry.